Hello बच्चों, let's read the question. Find the sum of infinite geometric series whose first term is the limit of the function fx which is equal to 1 minus tan x divided by 1 minus root 2 times sin x as x goes to pi by 4 and whose common ratio is the limit of the function gx which is equal to 1 minus square root x divided by cos inverse x squared as x goes to 1. Solution शुरू करने से पहले let's note down the key concepts for this problem. So the first key concept is for infinite geometric series with first term as a and common ratio r such that modulus of r is less than 1, then the sum is a divided by 1 minus r. The second key concept is L'Hopital's rule. L'Hopital's rule says that if we have functions fx and gx such that limit x tends to a point c of fx is equal to limit x tends to c of gx which is equal to 0 or plus or minus infinity, then limit x tends to c fx divided by gx is equal to limit x tends to c f dash of x divided by g dash of x. Now with these two concepts, let's now start our solution. So since in the question we have been given a geometric series, so let a and r be the first term and common ratio of the given infinite geometric series respectively. And since we know that the first term a is equal to limit as x tends to pi by 4 of fx, and that is equal to limit x tends to pi by 4 of 1 minus tan x divided by 1 minus square root 2 times sin x. Let's evaluate this limit to get the value of a. तो इसे evaluate करने के लिए क्या करेंगे? See, in the numerator जो हमारे पास function है 1 minus tan x, as x goes to pi by 4, as x goes to pi by 4, 1 minus tan x goes to 0, and as x goes to pi by 4, 1 minus root 2 times sin x goes to, see, जब x pi by 4 के करीब जाता है तब sin x की वैल्यू कहाँ पर जाती है 1 by root 2, and root 2 times 1 by root 2 is 1, and therefore the difference 1 minus root 2 times sin x goes to 0. So this limit is of the form 0 by 0. So this limit is of the form 0 by 0 form. So therefore we will use L'Hopital's rule. So the limit then simplifies to limit x tends to pi by 4, derivative of the numerator, that is derivative of 1 is 0, minus of derivative of tan x, that is secant square x, divided by derivative of 1 which is 0 minus root 2 times derivative of sin x, that is cos x. Now the limit simplifies to limit x tends to pi by 4 of secant square x divided by root 2 times cos x. अभी जब x की वैल्यू हम pi by 4 सब्स्टिट्यूट करेंगे तब this is not of the form 0 by 0. The limit does exist, and therefore, so evaluating the limit, we have limit x tends to pi by 4 of secant square x is 2 divided by root 2 times limit x tends to pi by 4 of cos x is 1 by root 2. So root 2 and root 2 gets cancelled, so the final value is 2. So therefore we have a is equals to 2. Now we need to get the value of r, and also we have to check whether modulus of r is less than 1. Since we know that r is equal to limit as x goes to 1 of gx function, that is equal to limit x tends to 1 minus square root of x divided by cos inverse of x squared. Again, if you see, as x goes to 1 minus square root of x goes to 0 and cos inverse x goes to 0. So again this limit is of the form 0 by 0. So let's use L'Hopital's rule. So now we have limit x tends to 1, derivative of the numerator, that is derivative of 1 is 0, minus of derivative of square root x, that is 1 divided by 2 times square root of x whole divided by, now derivative of the denominator, that is twice of cos inverse of x times minus 1 divided by square root of 1 minus x squared. Now this is equal to limit x tends to 1. अब ये नेगेटिव साइन कैंसिल कर देंगे, and so we have 1 divided by 4 times 1 by root x whole divided by cos inverse x divided by square root of 1 minus x squared. Now this is equal to 1 by 4 times limit x tends to 1 of square root of 1 minus x squared divided by square root x times cos inverse of x. Further we have r equals to 1 by 4 times limit x tends to 1 square root of 1 minus x squared divided by square root x times cos inverse of x. Abhi as x goes to 1, in the numerator we have square root of 1 minus x squared, that goes to 0, and square root x times cos inverse x also go to 0. Again this limit is of the form 0 by 0 form, indeterminate form. Now let's use L'Hopital's rule. So here we have 1 by 4 times the limit x tends to 1, derivative of the numerator, that is minus 2x divided by square root of, so half times square root of 1 minus x squared whole divided by derivative of the denominator. अभी यहाँ पर हमें डिफरेंशिएशन यूवी रूल अप्लाई करना पड़ेगा, तो यहाँ पर क्या आएगा, डेरिवेटिव ऑफ द फर्स्ट फंक्शन times the second function plus derivative of the second function times the first function. So here we have 1 by 2 square root of x times cos inverse of x plus square root of x as it is times minus 1 divided by square root of 1 minus x squared. Now let's simplify this. Further we have 1 by 4 times limit x tends to 1. So here we get, यहाँ पर माइनस और ये यहाँ से माइनस मल्टीप्लाई कर लेंगे, यहाँ से 2 कैंसिल हो जाएगा, क्या बचेगा कि we have x divided by square root of 1 minus x squared whole divided by, we will also take the LCM here, so we have square root of 1 minus x squared times cos inverse of x, नेगेटिव साइन है यहाँ पर, divided by twice of root x times root of 1 minus x squared, क्योंकि LCM ले रहे हैं, प्लस यहाँ पर आ जाएगा square root x और यहाँ पर root x times 2, so we have 2x. Now we see that square root of 1 minus x squared and square root of 1 minus x squared can be cancelled out, all because x goes to 1 but x is not equal to 1. Now this limit then simplifies to 1 by 4 times limit x tends to 1. Now if we try to simplify, we will have 2 times square root x times x divided by 2x minus square root of 1 minus x squared times cos inverse of x. अब इस लिमिट को हम evaluate easily कर सकते हैं by substituting x as 1. So here we get 2 times 1 times 1 divided by 2 times 1 minus 0, and so therefore we have 1. So this limit is 1. So the final value is 1 by 4. So therefore r is equals to 1 by 4 and modulus of r is less than 1. So therefore sum of geometric series, given geometric series, is equals to a divided by 1 minus r. Value of a is 2, value of r is 1 by 4. So therefore we have, simplifying, we get, so we have 2 divided by 4 minus 1, that is 3 by 4, and that evaluates to, here we get 8 divided by 3. So therefore sum of geometric series is equals to 8 divided by 3. So this is our answer. I hope you understood it well. Best of luck and thank you.